Okay, today I'm going to show you how to do a little bit of linear programming. Okay, so it's one of those topics that we do in the systems of equations where you have multiple equations and you're trying to maximize your value that works. So let me walk you through how to do one. Here's a screenshot of something you might run into on Alex. So you have the find the maximum value for this function. Z is equal to 4x plus 3y, subject to the following restraints. So what you're going to do first, okay, you're going to plot these restraints on Desmos. So go to Desmos, okay, plot those restraints in there. So here we go. We're going to type them all in. 5x plus 4y. So these are some of the limitations that this function has. It has to fit inside these parameters. So you're going to see they're all inequalities. They all should be shaded in a certain direction. So alright, so we got 10x plus y is less than or equal to 50. And we got another one. We got x has got to be greater than or equal to 0. We have y has got to be greater than or equal to 0. That makes sense. Okay, so if you look at it, okay, let me hide all this stuff here. Okay, where are they all overlapped at? Well, it's kind of hard to see because on Desmos it's kind of blending all the colors, but this brown section in here, right in here where my cursor is, that's the part in which any point in that area will work for the entire system. Okay, now where will the max point be? Well, that's a good question. See these ends or these boundary points, these are going to end up being where your maxes or your mins for that function is going to be. So these points right here in which I highlighted, which outline that brown section in which all of the inequalities overlap, where you want to test those values. So what I'm going to do, I'm going to get slick here. I'm going to use Desmos, okay? And I'm going to type in, let me see if this will work. Okay, so we're going to save some time. So what you're going to do is you're just going to type x would be 0, y would be 15, and you plug it back into this z function here, where z is equal to 4x plus 7y, or plus 3y. So I'm going to plug those in, but I'm going to use sliders just to kind of speed up the process here. So I'm going to say let a, I'm going to have a as a slider. Oh, hold on, how am I going to do that here? Let's say 4 times a, because I can't use x and y because I've already used x and y, plus 3 times b. And I want to add sliders to all, okay? I want to say what it's equal to. And I can't do that. Okay. Alright, so I'm going to add sliders to all. Let's see what happens here. If I change this value, okay, so A is going to count as my X, and B is going to be my Y. And as I move A, I'm increasing or decreasing X, okay? And as I move B, I'm increasing or decreasing Y. So what I'm going to do is I'm going to move these values to each one. So we're going to do 0, 15. So if A was 0, okay, 0, maybe. There you go. And B was 15. I'm going to have to change this step a little bit. We'll go up to 15. We'll go down to 0. Okay. So we'll go to 15 here. My output is 45. So I have a 45 for the first one. Now let's go to the second one. So the second one, let's go to this 410. So if A was 4 and B was 10, my output is 46. That's a little bit higher. If A was, okay, so that was this one. Let's do this 5, 0. If A was 5 and B was 0, my output would be 20. So that's a little bit lower. And if A was 0 and B was 0, which are my x and y's from those points over there, I would get 0. So which one's the biggest? Well, that would be this 46 right here. So that's saying when A was 4, when A was 4 and B was 10, remember those are just sliders I'm using to replace my x and y from my problem over here. Say you get 46. So 46 is the biggest one. So what's my answer? My answer is going to be what makes the maximum value? It'd be 4 and 10. There you go. That's it. So that's a little bit of linear programming for you. Not too bad. Desmos is pretty slick. You can kind of cut some work out using that. Okay? All right, good luck.